Welcome to section 16, covering probability. We are starting here on page 145. So on page 145, you will see a frequency table, which we have dealt with in the past. So to start, I want you to hit pause and fill in the frequency table, just that last column of proportions of customers. Remember, to find the proportions, we take the frequency divided by the total, turns it into a decimal, as you will see here, and then we can go from decimal to percent. So hit pause and finish out this table. Okay, so I asked you to complete it, and hopefully you ended up with a table that looks like this. So we've got the decimal and the percentages written here, and notice they should add up to 100% as a percent, 1 as a decimal, and 50 over 50 as a fraction. So now let's answer these questions. Number 1, what proportion waited 7 minutes? Well, 7 minutes is here, right? So I would say either 10% or 0.10. Either one of those would work as an answer for that. And number 2, if you select a customer at random, what is the probability they waited 4 minutes? Well, here's 4 minutes. And I would say probability 0.18. Generally, we talk about probability as a decimal. You could use a percent. Mathematically, it's equivalent. Number 3, probability of 1 or 2. Well, 1 or 2, we're going to add those together. So 0.02 plus 0.06, and that would give me an answer of 0.08 for the probability of waiting 1 or 2 minutes. Number 4, waited less than 10. Well, hopefully you notice that less than 10 is everybody. So all is less than 10, which gives me a probability of 1. Because 1 means it's definitely going to happen. It's all of them. Now, similar to that, in number 5, probability that they waited more than 10 minutes. Well, there is nothing more than 10, right? 9 is the biggest. So you say, well, this is nothing. And as a probability, that is 0, right? We can't have anything. If it doesn't exist, it's got a probability of 0. So the probability rules are written on the bottom of page 145, and they're going to be important for you to recognize. So basically, the first one, probability is between 0 and 1, right? If you have a probability of 0, right, it can't happen, right? It's totally impossible for it to happen. So in that last example, waiting more than 10 minutes, it was impossible. So you have a probability of 0. A probability of 1 means it's definitely going to happen. Going to happen. So when you say, waiting less than 10, well, that's 0 through 9, and that's definitely going to happen. You're going to fall in one of those spots. Probability rule number 2, you're going to have a total of 100%. We've talked about that, right? Because that talks about everything. And then number 3 talks about how you're going to find probability. So the number of items of interest. I always say what you want over the total possible. So that's the Becky way of explaining it. What you want over the total possible. So that's kind of what we're into here in probability. So let's go ahead and turn to page 146. All right, so at the top of page 146, you see, we call this a probability table, and this kind of helps us organize our data. So we have males and females. We're talking about police officers. We have those that were promoted in the last year and those that were not promoted in the last year. So that's how we're classifying. Now, when you think about it, we have 200 police officers total. Okay, well, how many males do we have? We have 120. 30 that were promoted, 90 that weren't. And how many females? 20 that were and 60 that weren't, for a total of 80. Notice when you add total male, total female together, you get a total of 200. Now, similarly, if I add the number of promoted, I get 50. The number of not promoted is 150. When I add those together, I get 200 total. So we've got a couple different ways to look at this. All right, let's answer some questions using this table. All right, so using this table, the first question is not numbered. It's right underneath the table, and it says, what's the probability of police officers female? Well, we're talking about, and I think it's important to recognize, what is the total that we're talking about? Well, we're talking about all police officers. So the bottom is going to be all police officers, and we know there are 200 of them. Okay, so in the top, we want to know about females. Well, if you look in your table, right, you have 80 females. So the top would be 80, and when we change that to a decimal, we end up with an answer of 0.4. So your probability of picking a female police officer would be 0.4. Now let's go to number 1, where it says what's probability a police officer is male. Well, you've got two different ways to do this. One, we can say there are 120 males out of 200 total, and that gives us 0.6, right? There's one way. Or you can say, well, I know that 0.4 are female, and if you're not female in this table, you're male. So I know that together the males and females have to be 1. So if I take all of the police officers, which is 1, minus the females, that would give me the males. So that's another way you can think of that question. And we do have a term for this. We're going to get to that in just a minute. Alright, so here in number 2, I forgot to put that there first, sorry. Number 2, what's probability a police officer selected at random was promoted? Well, again, we're talking about all police officers, so my denominator is 200. And how many were promoted? Well, 50. So I would get 50 over 200, or 0.25. So you got a 0.25 chance of finding a police officer that was promoted. Now in number 3, what about a police officer that was not promoted? Well, you either were promoted or you weren't, right? So one way to say all police officers minus those that were promoted, and we would find those that were not promoted. The other way to say was, well, we know 150 were not promoted out of the 200 total, and that also gives me an answer of 0.75. So either one of those works. Now, there is a word for this. When we are talking about two probabilities that are kind of like the opposite of each other, we call them complements. And we find complements by taking 1 minus the probability. So when we talked about number 2, the probability of being promoted, we know that promoted was 0.25. So if we talk about being not promoted, and the key word to complements is the word not, because not means, right, the opposite. So to find it mathematically, we would take 1 minus whatever the probability is for promoted. So when you see not promoted, you would take 1 minus promoted, and that gives you 0.75, which is called the complement. So 1 minus finds you the complement. Okay, let's continue on with number 4. So now we're going to look at the word and. You'll see we did not have the word and before, and now we do. So now we want to find the probability of finding a woman and someone who was promoted. Well, probability of a woman and was promoted. So when we look at our table, and we're trying to find the probability of a woman who is a woman and was promoted. Well, a woman and promoted is right here, because that's where the females and who were promoted. So we would take 20 over all the police officers, because we're still going out of police officers. Selecting a random officer who is a woman and was promoted, and that gives us 0.1. Let's look at number 5. Get rid of the marks here. Number 5 says, find the probability of a man who was promoted. Well, here are the men, here's promoted. So the intersection, right, and kind of means intersection. So a man who was promoted is 30 out of 200, which is 0.15. All right, moving on to page 147. Okay, now in number 7 we get the word or. So this is a little bit different. We want to find the probability that we have a female or they were promoted. Now there are 2 ways you can do this, and I want to show you both methods. So the first method we'll do in orange. Female. Well, we know that the female is here. All right, so that's 80 over 200, or promoted, and we know that promoted is here, which is 50 out of 200. Hopefully you recognize that this part right here is counted twice. They're counted in the female and they're counted in the promotion. So we would have to subtract the overlap, and we end up with an answer of 110 over 200, which is 0.55. Now that's one way to do it, is add the 2 together and subtract the overlap. The other way, let me change colors for effect, because, you know, it's all about the color. Let's go to blue. We're still dealing with female or promoted. So when you look at that, I want to change to a different shade of blue for effect, because this is what I do. We've got 3 pieces that are involved here. So the second method would say I've got 30 males who were promoted, I've got 20 females who were promoted, and I've got 60 straight up females, right, who were not promoted. And if I just add those three together, I get 110 over 200, and that's 0.55. So I don't really care which way you do it. Either one of those is fine. But I think that's pretty important to recognize the differences. So if you have questions on that, let me know, and I can kind of go into more than that. All right, so now let's move to the bottom of that page. Now in number 9, we get into what we call conditional probabilities, and it's conditional because they kind of give us a starting point. If the PO is a woman, so now we are only focused on the females because it says if we have a woman. So now that is all you're talking about. You don't care about the men. We only care about the women. So now our total is 80 because that's the total of the women that we have. So what would be the probability she was promoted? Well, how many women were promoted? 20. So 20 over 80 is 0.25. So if it says if the police officer is a woman, you're only worried about the women. All right, let's go to number 10. All right, so number 10 they say if the police officer was promoted. Well, now we're only worried about those that were promoted. So our denominator would be the total promoted, which is 50. What's the probability that it was a woman? Well, there were 20 women that were promoted. So out of the promoted, 20 out of 50. So we would end up with 0.4, right? So it all comes back to if the PO was promoted. So we're only worried about those that were promoted. All right, I want you to try 11 and 12. Hit pause and try 11 and 12. All right, so looking at number 11, given that the PO was promoted, all right, so once again we're dealing with promoted, total is 50, hard color to see there, let's go to 50. Probability that it was a man, well, 30 of the promotions were men, so we end up with a 0.6. Now look at number 12. What is the probability it was a man if they were promoted? So now it's backwards, but the wording is, the wording is backwards, but the concept is identical. What is the probability it was a man if they were promoted? So again, if they were promoted, probability was a man. 11 and 12 are identical. The wording is just a little bit differently. All right, we're going to call that video number 1.